The videos that you're about to watch, I'm going to walk through my thinking and what I would do to answer some of the questions on your homework worksheet so that if you got sort of stuck, you can watch and sort of see how to potentially solve or answer the questions. So the first half of this worksheet focuses on this idea of types of change, specifically the difference between absolute change and relative change. Absolute change is sort of the overall change versus relative change is focusing more on a percentage. So starting right off the bat, we're looking at a problem that looks at the difference in average cost of milk. So back in 1999, it cost $2.88, and today milk sells for $4.41 on average, and I want the absolute change. So that's going to be as simple as taking the new value, the price we're now at, and minusing the original cost. And I know that milk now has gone up by $1.53. Sort of, that's how much the price of milk has increased since 1999. Now, that's giving me just sort of, okay, it's gone up $1.53, but let's sort of put this in terms that show how much $1.53 really is, because that doesn't seem like a lot. So there comes the advantage of relative change. So what if we figured out what was the percent increase in that price? And basically to figure out the percent increase, you're going to take that absolute change, so that $1.53, and divide it by the original price, the $2.88, and that's going to come out with a decimal. So I would get 0.531. Now we want to write our relative change as a percent, so we would times that number by 100, and we would find out that the price actually has increased 53.1% increase. And when I say it that way, all of a sudden I'm like, whoa, milk's gone up a lot in the last 20 years. So that's sort of the difference between an absolute change and a relative. We're looking at just sort of the dollar amount that it changed versus sort of thinking more in terms of percentages, which allow us to sort of compare different growth. All right, so the next problem, we're actually comparing different revenues. So in this particular case, we're told that revenue in Washington totaled $156 million. In Oregon, it was $60 million. And in that same year, Colorado had $200 million. And we're being asked to treat Colorado sort of as the standard and compare the revenue in Oregon to that. So to do that, you're going to take the revenue so we're asking now for an absolute difference. The reality is an absolute change and an absolute difference have the same formula, but sort of what you're using them for is the difference. An absolute change, I'm comparing the same thing at two different points in time, and I'm looking at how that one object changed. An absolute difference, I'm comparing two separate entities and sort of looking at what is sort of their difference in price or revenue or cost or heights or whatever else I'm sort of measuring. So here it's revenue. So if I'm comparing, I start with the one that I am comparing to, which is the $60 million in Oregon. And I then take away the standard. And so the standard is what you're comparing that 60 million to, which in this case is the 200. So standard compared minus standard, and I end up with, Oregon made $140 million less. So if I were to describe that, I would say, Oregon revenue was $140 million less than Colorado's. So notice we're comparing one to another. Similarly, a relative change versus a relative difference, again, we're looking for a percent change. The formula is pretty much the same, but we're comparing two separate entities again. So in this case, to do my relative difference, I'm going to take that absolute difference, that negative 140, and divide by the standard I'm comparing it to, that 200. And I would get out negative 0.7, which is basically saying a 70% less. So Oregon's revenue was 70% less than Colorado's. Now, does that mean Colorado's revenue was 70% more than Oregon's? No, that's not how this works. So this would be a no. You know, I can say that Oregon's revenue was 70% less than Colorado's, but percents don't just work with like a flip. If I wanted to figure out how much more Colorado's revenue is, I would need to redo my relative difference, making Oregon the standard, and I would get out a number. So this 70% just tells me that Oregon's revenue was 70% less than Colorado's to flip it around, I would need to change my standard. A statement like the one given, I'm not going to fill this all in, but I would need to recalculate my relative difference using Oregon as the standard and Colorado as the one I was comparing it to. All right, so let's keep going. If we take a look at number 3, we're being asked to compare gas prices, and we're given a sort of average cost in the Phoenix area back in 2017, and then we're given the lowest price gas station. So I like to think if I'm comparing two things and I'm asked for absolute and relative terms, I like to make the average one my standard, and the other one then my comparison. So in this case, if I'm going to find my absolute, just put a little note, absolute, I would start with, my 215, the one I'm comparing it to, and then that 233 average becomes my standard. And so I find out that lowest gas station was about 18 cents less per gallon than the average in the Phoenix area. Now, if I then want to figure out the relative, I would take that absolute difference, that negative 0.18, because remember it was less per gallon, and I would divide it by my average price per gallon and turn it into a percent and end up with a 7.7% less. So the lowest cost gas was 7.7% less per gallon than the average. All right. So again, we can sort of keep doing this. And 4 should be done similarly to the previous problems. The absolute comes out to be 10,814.22, and the relative was 77.2% increase. So that's pretty similar to the previous problems we did, so I'm not going to walk through it. 5's a little different because we're looking at comparing population densities. So before you even begin with these problems, you would need to find the population densities and then go through and compare. And when you're finding the population densities, you do need to make sure that they're in the same units. So I converted that 9.3 million square kilometers into 5.78 million square miles. And so like the population density for the US, so I'm going to just put D of US, would be population, which is 327.1 million people, over the area. And I'm going to convert that into millions of square miles, just like the China area. So that would be 3.531 ... And that's going to get you the population density of the US. I'm going to use that number as sort of my comparison piece, and I would need the density of China, which would be the population of 1,412.7 million, which is basically a billion people, over the area, that 5.78 million. And this would get me people per million of square miles, just as this would get me millions of people per square mile. If you go through and then do the calculations, which I'm not going to show you again here because they're similar to the previous calculations we've been doing, your absolute difference should come out 151.8 million people per square, actually it's per million square mile fewer. So it was a negative value, just as it would be negative 62.1% less. So 62.1% less millions of people per millions of square mile compared to China. All right. I'm going to keep giving a few answers and then jump ahead to number 7. So just the answers on 6, your absolute should have come out as $5.65 per barrel more. And so it was a 12.5% increase. All right, number 7. The reason why I wanted to make sure we go over number 7 is number 7's looking at comparing accuracy. So sort of focused on error. When you're doing that, your standard is going to be the correct value. So in this case, we're told that the second scale is deemed to be correct. So that 55,500 tons is going to be my correct value. And the 57,000 is my sort of one I'm comparing it to. So when I go through and do the absolute, it's going to be 57,000 minus 55,500. And so I find out that the first scale was 1,500 tons too high. And then if I want to go through and do the relative, I would take that 1,500 and I would divide by my 55, my correct value, 1,500. And I would find that it was about 2.7% too high in the weight. So like it was about 2% off, 3% off. I'm going to keep giving a few answers. So 8 again should be like previous ones. The absolute should come out at negative 68 and the relative comes out at negative 73.1%. And then we get to number 9. I like number 9 because our data points this time aren't numerical values. They're not dollars. They're not cents. They're giving us percents. So we have the original value was 4.3% in 2011. And then in 2016, it was 2.2%. So if I want to find the absolute and relative change, I'm not subtracting numbers, dollars, people. I'm subtracting percents. So my absolute change is going to be 2.2 minus 4.3, which came out as negative 2.1%, which basically says, the number of middle schoolers smoking went down 2.1%. Now, if I want to turn that into a relative, I'm finding a percent of a percent, the percent change of the percent of the population. So in this case, I'd take that absolute difference, that negative 2.1%, and I would divide by 4.3%, and I would end up with a change of negative 48.8%. So basically 48.8% fewer people, fewer middle schoolers, it's sort of that percent went down that percent, if that makes sense. Now, do we have enough information to make conclusions about the number of middle schoolers? No, because nowhere in here are we told how many people were part of this study. So we're told about 2 out of every 100 middle school students, but we weren't really told how many middle school students. So we can't make a conclusion about the numbers of people involved without knowing more information about the situation. All right, so that's me walking through all the problems that specifically focused on relative and absolute changes and differences. Watch the next video to sort of see me walk through the rest of this homework worksheet.